Focus on learning how to graph quadratic functions. We've actually already done some graphing of quadratic functions in lesson 1, but this is going to be a different way of doing it. We're going to do it without using a table of values, just by using the information in the equation. So as you can notice on your notes, there are 6 steps to graphing quadratic functions. These are not quick and easy problems. It's going to take you some time to graph. If you'll take them one step at a time, they're not hard. It's just not something you can expect to do really quickly. Where we tend to make mistakes is when we try to take shortcuts and try to move too quickly. That's where the mistakes come from. But if you'll follow each step, step by step, they're really pretty simple. Alright, so at the top of your notes it says, recall that a y-intercept is the y-coordinate of a point where a graph intersects the y-axis. The coordinate of this point is always 0. For a quadratic function written in the form y equals ax squared plus bx plus c, when x equals 0, y equals c. So the y-intercept of a quadratic function is c. So what you need to take from that paragraph is that when a quadratic equation is in standard form, the value of c is the y-intercept. Which means when you graph that equation, the parabola is going to cross the y-axis at that number. So you can see that illustrated in all 3 of these examples. The y-intercept is the same as the c value. As you notice, the c value in the equations is the one without an x. So in the first example, it's -2. Look at the graph. The parabola crosses the y-axis at -2. Over here, the c value is 4. The graph crosses the y-axis at 4. So that's one of the pieces of information that we're going to use to help us graph. All right. The first example says graph y equals 3x squared minus 6x plus 1. So we're going to go through write out the steps as we work through this problem. The first step is to find the axis of symmetry. So we already know how to find the axis of symmetry. How do we do that?
Negative b over 2a.
Negative b over 2a. Good. So in this example, b is what?
6.
And b is -6, and c is, a is, 3. So when you plug that into the formula, you're going to get what? 6 divided by 2 times 3, which is 6 divided by 6, or 1. So the axis of symmetry is 1. Step 2 is to find the vertex. We already know that the x-coordinate of the vertex is 1. We know that because the axis of symmetry is the x-coordinate of the vertex. To find the y-coordinate of the vertex, what do we do?
Put x into the equation.
Put 1 into the equation. So you're going to do 3 times 1 squared minus 6 times 1 plus 1. So I need everybody to take out their calculators. You do not want to try to do this section without a calculator. Take out your calculator and put this into your calculator. I want everybody to practice in class so that if you are having trouble with your calculator, I can help you. Do you have your calculator?
No, but I got to.
So if you plug that in correctly, the correct y value is -2. Step 3 is probably the easiest step. Step 3 is to find the y-intercept. We just talked about how to do that. You can find the y-intercept simply by looking at the equation. What's the value of c in the equation? 1. So the y-intercept is also 1. In step 4 is where we're going to actually start graphing. You're going to go ahead and graph the points that you have. So in step 4, you're going to plot the vertex, draw the axis of symmetry, and plot the y-intercept.
Wait, how do you get y-intercept 1?
Because c is 1.
Oh.
So here's what I mean by that. Plot the vertex. So plot the point 1, negative 2, which is right here. The next step is really important. Unfortunately, some people try to skip this one, but if you do it, it's going to make the problem a lot easier. Draw the axis of symmetry. Hopefully you remember the axis of symmetry is a vertical line that goes straight through the vertex. So the vertical line that goes straight through the vertex, I draw it dotted because it's not actually a part of the parabola. Then plot the y-intercept. The y-intercept is 1, so that's right here. So as you can see, so far I cannot see any type of parabola forming. So I'm going to need to plot a few more points in order to see the parabola forming. So step 5 is to choose 2 more x values that are on the same side of the axis of symmetry as the y-intercept. Okay, so let me show you what I mean. If you look back at the points you've plotted so far, you can see that the axis of symmetry is here and the y-intercept is here. So the y-intercept in this example is to the left of the axis of symmetry. So when you're choosing 2 more x values, you only want to look at x values that are to the left as well. So if you look at the x-axis, you have -1, -2, -3, -4, and so on. You can choose any of those values. However, the further away you get from the axis of symmetry, the bigger your points are going to be. So if I choose -5, my point is probably going to be way up here and way off the graph. So in order to make the graph a manageable size, it's in your best interest to choose the 2 x values that are closest to the axis of symmetry, which in this case would be what? -1 and -2.
Oh wait, actually, could it be 0?
No, why not?
Because it's...
You already know the point that's on 0.
Yeah. Great job.
Okay, now I have the x values. How am I going to figure out what the y values are? Plug it into the problem. So I need to do 3 times -1 squared minus 6 times -1 plus 1, and 3 times -2 squared minus 6 times -2 plus 1. So do both of those on your calculator. So what do y'all get when you plug in negative 1?
10.
10. What do you get when you plug in negative 2? 25. Good.
Wait, why do we have to find the vertex? I don't understand how.
Because you have to plot it on the graph.
Oh,
That's the point that I put right here is the vertex. Okay, the last step and probably the most important step is to plot those points. Plot those points and reflect them across the y-axis. So here's what I mean by that. You need to plot those points on the graph. So we have negative 110 and negative 225. In this case, since negative 225 is so far off the graph, don't worry about that one. We'll just plot negative 110. If you look at your graph, you can start to see that on the left side, it's forming half of the parabola. If you connect those points, you can start to see that it's forming half the parabola. What I need is the other half of the parabola. The other half of the parabola, all you have to do is reflect these points over. Remember, parabolas are symmetric, meaning whatever's on the left side is the same that's on the right side. So if there's a point 1 unit to the left here, that same point is going to be 1 unit to the right on this side. If there's a point that's 2 units to the left here, the same point is going to be 2 units to the right here. So once I reflect those other 2 points, I can now see the whole parabola and connect the points. Okay, let's try, we're actually going to skip this example. Let's try the one on the back. Y plus 6x equals x squared plus 9.